Dear students, viewers, I'm here to explain today. It's that is part of uh, that is from calculus. It has two parts. First one is differentiation. Second one is integration. So I'm here to explain first of all some techniques of differentiation. Okay, so to know differentiation, to learn, you have to do some techniques, you have to know some techniques, uh, some formulas to solve differentiation. Okay, first of all, let's see what's the use of differentiation. Okay, now suppose if we draw a straight line, it's here, and let me consider here 2 points. Suppose this point is x1 y1, this point is x2 y2. When we are finding out gradient of these 2 points, that is m equals to y2 minus y1 divided by x2 minus x1. Okay, but question is that if it is straight line, it's alright. If it is curved line, then how can you find out gradient? Suppose this is the curve, this is the curve. Okay, this is the curve. When you are finding out gradient, there are you can draw tangent everywhere. You can draw tangent. That line which is touching the curve, it is called tangent. So this is the, if you consider randomly 2 points, you will find out gradient in that way. In each point you are having different gradients. So it would be better if we use some techniques or formulas to find out gradients. Techniques, I can give you some basic formula, that is number 1, ddx of a x to the power n equals to a n x to the power n minus 1. 2, ddx of x to the power n equals to n x to the power n minus 1. 3, ddx of x equals to 1. 4, ddx of some constant, that is 0. So first of all, try to memorize these few formulas. ddx of ax to the power n equals to a n x to the power n minus 1, ddx of x to the power n equals to n x to the power n minus 1, ddx of x equals to 1, and ddx of constant equals to that is, first of all, see these types of maths. It's very easy to solve. Y equals to 2x to the power 3 plus 2x plus 5x plus 3. Okay, now differentiate with respect to x. Let me differentiate with respect to x. You will consider x as a variable, rest of the things compared to x are constant. So now see, when you are differentiating, take ddx on both sides. It's quite lengthy to write, but for the first time I'm writing. Later on I'll ignore it, I'll do the calculation mentally. Now see here, this is 2, this is 3, this is actually 3 minus 1. See, this is 2, now let me take this here, 2 minus 1. ddx of 5 into x is 1, and ddx of some constant, that is 0. So what formula I have used? That is ddx of a x to the power n equals to a n x to the power n minus 1. This formula I have used here. Now let us simplify. 6x squared plus 4x plus 5. This is the differentiated result. Okay, now this is a main function, and dy dx This is called gradient function. This is called gradient function. Now on that graph, suppose there is a graph. If you choose randomly any point from the graph, suppose x equals to 1, x equals to 1, so dy dx will be 6 plus 4 plus 1 if you replace x by 1. This is the gradient 15. So gradient at x equals to 1 equals to 15, I mean positive 15. So let me write chain rule. Chain rule. Okay, suppose if a question is written y equals to 2x plus 3 to the power squared. Okay, now it's given to find out dy dx. We can easily do that after expanding this one. Y equals to 4x square 3 to the 6, 6 to the 12x plus 9. Now we can differentiate. Dy dx equals to 4 to the 8 x, 2 minus 1 1, then 12, then some constant, that is 0. This is the derived function. I am differentiated this expression and we have got this one, dy dx equals to 8x plus 12. Now question is that if power is higher than these two, suppose that means suppose y equals to 2x plus 5 to the power 19. Now is it possible to expand using binomial expansion? Obviously possible, but it's lengthy process. So there is a shortcut way to solve this. So we will today follow that shortcut way. Now we will consider this as a blah. Let us consider ddx of blah to the power n. So let me solve in that way. Blah n minus 1 ddx of blah. There is another method also you can solve. So let me do it first. All the time I will follow this one. So suppose this is the blah. Let me write here dy dx equals to, this is the blah. So 19. Let me keep blah same. 19 minus 1. Okay. Then ddx of 2x plus 5. Now let us simplify. 19, 2x plus 5 to the power 18. X is 1, so 2 plus 0. Now let me simplify. 19 times 2, that is 38. 2x plus 5 to the power 18. So we have done, this is a shortcut way. I think I'll suggest you to follow this method. It's a very good method to solve. Now, okay, so let us consider, this is the second method of chain rule. Let us consider let u equals to 2x plus 5. So y equals to u to the power 19 and u equals to 2x plus 5. Let us differentiate. Du dx equals to, that is 2. Now dy du, you are differentiating with respect to u. It will be 19 u to the power 18. Okay. So you are finding out dy dx equals to dy by du into du by dx. Let me replace it. 19 u to the power 18 into 2, so 38. There is nothing u in this question. U is replaced by 2x plus 5 to the power 18. This is the answer. So this is another way to solve. If you have confusion regarding first method, I hope you can understand this one. Product rule. Okay, when we can apply this product rule? Suppose y equals to 2x plus 3 to the power 5. Let me write here. Then x minus 7 whole to the power 3. Now see, this is in terms of x, this expression is also in terms of x. So if we expand it and if we multiply it, it's a big problem, it's a big calculation, it's quite challenging for us to do. Now when you are solving this, keep it in your mind, that is it's two expression with multiplication sign. So we can apply product rule. We can consider here u, consider here v. So let me see the formula first. uv equals to u dv by dx plus v du by dx. Now use this formula. If you can use this formula, but be careful for chain rule. Chain rule must be applied everywhere. So let me consider here u and this. So dy by dx equals to, keep u same, and ddx of v is x minus 7 3 plus v, same v, x minus 7, and ddx of x plus 3 whole 5. Now let us simplify. X plus 3 whole 5 into 3 x minus 7 squared. See, if we do chain rule here, it will be 1 and 0. So let me write here 1 and 0, chain rule. And x minus 7 whole cube equals to 5 x plus 3 whole 4. If you apply chain rule, 1 plus 0. So chain rule, if you can use chain rule properly, there is no scope to make mistake. Now there are some common things you can take it. Now algebraic calculation, that is 4, then x minus 7 squared. Now see, it's here x plus 3 to the power 4 into 3 plus x minus 7, x minus 7, that is 5 also here. Now simplify this. X plus 3 to the power 4, x minus 7 square. If you can, 3x plus 9, 5x minus 35. If you simplify this, you are having x plus x minus 7 squared, 8x minus, if you subtract this, 35. If you subtract 5, then 4, maybe 26. Okay, so you can take common 2 and you can do simplify more. So this is what we have done from product rule. If you see two expression with multiplication sign. Now what will happen if the expression is given in division? Quotient rule. Let me write here Q rule. Okay, it's Q rule. Quotient rule means there will be some expression. Suppose y equals to x by x plus 1. Okay, x by x plus 1. Now how can you solve it? This is u, this is v, that is, it is in the form of u by v. So let me write here ddx of u by v equals to, that is v square v d dx of u minus u ddx of v. But problem is that we are confused all the time. What will be, should I write here u first or v first? But be careful, this is v, so this is v. And another way to remember, v du. Okay, now we can apply this formula here. See, when you are finding dy dx, you can write here x plus 1 whole square, x plus 1 ddx of x minus x ddx of x plus 1. Now simplify this one. X plus 1 whole square, and then x plus 1 minus x. Here will be 1 plus 0. Keep it same. Now see, this is the result. 1 by x plus 1 whole square. Trigonometric differentiation. We should learn these two formulas. ddx of sin x equals to cos x, and ddx of cos x equals to minus sin x. Now for exponential and logarithmic functions, keep it in your mind, ddx of e to the power x equals to e to the power x, ddx of ln x equals to 1 by x. Now it's quite challenging to remember, but in practice we have learned what is cosec theta is equals to 1 by sin theta, that is sec theta equals to 1 by cos theta, cot theta equals to 1 by tan theta. Same way, tan theta equals to sin theta by cos theta, cot theta equals to cos theta by sin theta. Sin square theta plus cos square theta equals to 1. I mean trigonometric form of Pythagoras theorem. 1 plus tan square theta equals to sec square theta. 1 plus cot square theta equals to cosec square theta. Even ddx of tan x, we can write it ddx of sin x by cos x. Now you can remember this is in division form, I mean u by v. So now u by v, we learned this formula, that is ddx of u by v equals to down v square v du dx minus u dv. So same thing I'll apply here, v square then v ddx of u minus u ddx of v. Now let us simplify this one. Now we have done our work. I have shown you already to memorize this one. ddx of sin x is what? Cos x. ddx of sin x is cos x minus, keep it same. ddx of cos x is what? Minus sin x. Okay, exactly, minus sin x. So this is cos square x. So here will be a cos square x minus, plus sin square x. That is cos square x. So cos square x plus sin square x is what? 1 by cos square x. So 1 by cos what? Sec square x. So ddx of tan x is sec square x. ddx of cot x. Cot x means ddx of cos x by sin x. So we can write here sin square x, that is sin x ddx of cos x minus cos x ddx of sin x. Now let us simplify. Sin x into cos x, if it is differentiated, cos x, what can it be? Minus sin x. Cos x, this will be sin x, will be cos x. Let me keep it same, sin square x. So this minus will be common. So sin square x plus cos x square x divided by sin square x. Now sin square x plus cos square x equals to what? 1. Sin square x plus cos square x equals to 1. So it is becoming 1 by sin square x. So if you simplify, this is cosec square x. Sec x, we can write it ddx of 1 by cos x. Okay, ddx 1 by cos x. Now let us write, that is ddx of cos x to the power minus 1. Let me take it before, then cos, chain rule must be applied, ddx of cos x. Okay, now minus, we can write it 1 by cos x square into this cos x is minus sin x. So minus it is becoming plus. Okay, so sin x by cos square x. That means we can simplify more. 1 by cos x into sin x by cos x. What about 1 by cos x? 1 by cos x is sec x into tan x. That is, we are having sec x tan x. Now we have got sec x. Now last thing, that is cosec x. So let us ddx of cosec x equals to ddx of 1 by sin x. Chain rule, but be careful, be cautious for chain rule. ddx of sin x minus 1. So minus 1 will be here. Sin x to the power minus 2. ddx of sin x. So you know ddx of sin x is cos x. Let us arrange it. Minus 1 by sin square x into cos x. Okay, now see here, 1 by sin x cos x by sin x, so it is minus cosec x cot x. ddx of a x to the power n equals to a n x to the power n minus 1. Done. 2 ddx of x to the power n equals to n x to the power n minus 1. 3 ddx of x equals to 1. 4 ddx of some constant equals to 0. Now next thing is that product rule, ddx of chain rule first, blah n equals to n blah n minus 1 ddx of blah. Now if I go for 6 ddx of product rule, u dv dx plus v du dx. 7 ddx of u by v equals to v square v du dx u dv dx. 8 ddx of sin x equals to cos x. 8 9 ddx of cos x equals to minus sin x. ddx of 10x equals to sec square x. ddx of cot x equals to minus cosec square x. ddx of sec x equals to sec x tan x. ddx of cosec x equals to minus cosec x cot x. ddx of dx equals to e to the power x, and ddx of ln x equals to 1 by x. So try to get all this formula, and thank you very much for today. Wait for next lecture to get more information regarding your that is trigonometry, I mean calculus.